Okay, here we go. Direction angles. All right, so what do we know about direction angles? If u is a unit vector such that theta is the angle measured counterclockwise, just like in the trig, we go counterclockwise from standard position from the positive x-axis to u. That is exactly the standard position from trig. The terminal point u lies on the unit circle. Okay, well obviously if it's 1 unit away, it would have to lie on the unit circle, right? Because that's 1 unit away. So there's a point, there's our vector u, there's an x, there's our y. Oh, remember from trig, y is the same as sine theta and x is the same as cosine theta because r is 1. Remember, sine is opposite, there's our angle, opposite over hypotenuse. And if the hypotenuse is 1, it's just that. And cosine is adjacent over hypotenuse. And if the hypotenuse is 1, the cosine. So y equals sine and x equals cosine. For our unit circles, it's going to help us out. So now we know, let's say u is equal to xy. That means it's also equal to cosine theta, sine theta, because that's x, and that is y. And we can add the i's and the j's. So, if v is ai plus bj in any vector in the same direction and have the same direction as u, then we know this. The magnitude times this cosine theta, sine theta will be our vector. So look at it. I just need to add my i's and j's. Oh, okay, right, just from up here. I'm just taking that times that right up there. And notice, oh, A in front of an I, B, the value's in front of the J. So the tangent theta, remember what tangent from trig is sine divided by cosine? So let's look what we got. If we type all this up right here, guess what's going to happen to those V's? And that is all equal to what? That's equal to B. This is equal to A. So the tangent theta is simply equal to what? B divided by A. Now that's the definition of the tangent angle. So here's what you actually do. What does it mean, Coach Stoney? That's all nice and fancy, but Coach Stoney, just tell me what I got to do. Here's what you got to do. Find the direction angle for any of these vectors. Let's look at A. Remember, tangent is B over A. And remember, B is the front from J, A is in front of that. Coach Stoney, that's it? Pretty much. Tangent, 3 over 3, that's 1, right? And think about it. If your tangent is 1, 3 over 3, what's that angle going to be? 45 degrees. Remember, when tangent is 1, it's a 45-degree angle. Whoa! Remember I got to remember all my trig stuff? Well, yes and no. Let's look at the B problem. Now remember, tangent theta is equal to B over A. The B is going to be the what? Negative 4 over the 3. There's our graph. So I want to find that theta angle, right? Well, remember this. Our angle is simply this. The arctangent. So basically go to second tangent, parentheses, negative 4 divided by 3, and we got this answer, ooh, negative 53.13, which is the angle right there. But our direction angles have to be positive. Well, if this is negative 53.13, how can I find that? Well, how many degrees are in a circle? 360. So add the 360 with the negative 53.13. So the actual answer to this one is 306.87. But it's really simple. If you work this problem out and it's up in quadrant 1, your answer is just going to be positive. You have to check to look for your quadrants to know, just like we did if these are trig stuff for these particular things right here for these direction angles. All right? They can be tricky.